Welcome back. Today, I'm going to be going over this SAT question, which has to do with margin of error. And of course, this is going to be a Module 2 type of question. So I would encourage you to try first before I get started on the explanation. Okay, so I don't want to waste any of your time, so let's get right in. Here we have a city, right, which conducted two independent surveys of its residents to estimate the percentage who support converting a street into a pedestrian-only area. And of course, they give us information on the first and second survey, right? Essentially, right, we're asked what is the minimum possible increase in the number of residents, right, who support the change. So now you'll notice, right, of course, there's a margin of error in this problem, right? We have that in the first survey, there was a 2.3% margin of error, and in the second survey, there was a 1.0% margin of error, right? And that margin is applicable to the estimated percentage of residents, right, who supported the change. So I'm going to go off to the side for a second, right, and just explain what margin of error even is, right? Let's say, let's actually use the numbers here, right? Let's look at the first time. So we have that the estimated percentage, right, of residents who support the change was 48.6, right? And notice it says estimated, right? That's a good sign also that that's also a clue as to why this problem is even including a margin of error, right? But 48.6, right, was that percentage, and the margin of error was 2.3%. What that means, right, is that the actual number of residents who supported the change, right, it could be 2.3% greater than the estimate, or it can be, 2.3% less than the estimate, right? So, in other words, for the first survey, right, because these numbers are for the first survey, the maximum could be 48.6 plus 2.3, right? And the minimum, of course, is if you subtract 2.3, right? So yeah, margin of error just gives you the range of all the possible values that it could actually be, right? So in this case, let's just solve it, right? Because we probably will need to in some point at this problem. So if you do 48.6 plus 2.3, you get 50.9, right? And of course, if you subtract 2.3, right, you get 46.3. So the interval is between those two numbers, right? It could be the actual percentage of residents who support the change. It could be between those two numbers, right? Similar logic for the second survey, right? The range, well, it's going to be 52.1% minus that 1% margin or plus, right? So it can really be 51.1% to anywhere from between those, between 51.1 and 53.1, right? So yeah, again, this is the min, this is the max, and just write that here also, right? This is the min, this is the max, right? And of course, this is the first survey, and here, this is the second survey. All right, so now let's look at what the question is asking. It's asking what is the minimum possible increase in the number of residents who support the change. So, of course, there's two surveys here, right? They're asking us to find the least possible increase, right, in the number of people or residents that voted, right, between these two surveys. Well, how would you find the minimum possible increase? This is where optimization comes in, right? Where you're trying to optimize the value. In this case, because we want the smallest possible increase between the two surveys, what that means is we want the highest possible percentage from the first survey, right? And we want the lowest possible percentage of the second survey, right? That's how you get the minimum increase. Another way to kind of think about that, well, let's say you could think of this maybe, and actually I kind of do find it helpful to think of it as distance almost, right? Let's say you have a number line here, right? Let's make 5 numbers. 1, 2, 3, 4. Make this 5. Let's just put this 0. Okay, so now let's say you're somewhere in this area, right? And let's say your friend is somewhere in this area, right? On this number line somewhere. So you're between 0 and 1, and your friend is between 4 and 5. The closest you guys can be to each other, right? The minimum distance, well, it's going to be on the outer edge, right? So it's going to be the maximum of your location, which is 1, and it's going to be the minimum of your friend's location, which is 4. So that's how you get the minimum possible distance, right? That's how you're trying to optimize those two intervals of error to get the closest possible distance. This is a very similar scenario, right? Um, we want, of course, right? Think of this as your friend, as you, right? So think of this as your area, and think of this as your friend's area, right? We want the largest possible percentage of your area, right? And we want the smallest possible percentage of your friend's area, right? That's how you get the minimum increase, or like the minimum distance you could think of. So, well, what is that? What's the maximum possible number for the first survey? Well, I told you that 50.9 was the max, right? Because we calculated that earlier. So it's 50.9%, 50.9. In Desmos, you can actually put percent right there, right? But I'd actually encourage you to divide by 100, right? So this becomes 5.509. And of the population, well, the population differs. Uh, of the first at the time of the first survey, the population of the city was 251,000. So you do times 251,000, right? So that's the maximum percentage of residents in the first survey who supported the change. Now, of course, I told you earlier we want the smallest possible value for the second, right? We calculated that earlier, right? It was 51.1. So you do, once again, convert to decimal form, divide by 100. So you do 0.511 times 253,000, right? And you get that number. So once again, that thing we just calculated right now, that represents the smallest percentage of residents who supported the change in the second survey, right? In the second one. So now, well, how do you find the increase, right? Well, just subtract those two, right? Of course, that minus the previous number we got for survey one, and you get the number 1152, or sorry, 1524, and that's, of course, matches with answer choice C, right? So once again, right? First, recognize that margin of error is really just an interval of where the actual value could be, right? In this case, where the actual percentage of residents who support the change could be. And if we're trying to find like the max or minimum increase, right? Just optimize it, right? Think about it logically. Like hopefully this distance example here makes sense, but just think about what you need to change about the first and second um, surveys, or like datas, right? Data sets, it could be anything, so that it gives you that optimal maximum value or that optimal minimum value, right? Or that optimal increase or decrease, right? So once again, if you have any questions, of course, right, leave it down in the comments. But that's it for this video. I'll see you next time.